All right, so now we are at the very last experiment for this lab number 2. So far, using lab number 1 and lab number 2, you have pretty much found the every parameter in these equations. You know, mechanical parameters, you know, the RE and KE parameters, and you also know how the voltage conversion happens from the command given in the DSC value given in Arduino to the actual voltage that goes to. So you have all these relationships now, okay? Using all this, you are completely ready to find the transfer function of the motor from voltage to speed. And remember, this is a slightly nonlinear, I mean, not nonlinear, it has a constant in it. To make it strictly linear equation, we're gonna take this constant and subtract from VA. So that's the voltage that's needed to actually make the motor move. So transfer function from that moving voltage to the speed of the motor, that could be obtained. Okay, great. Now you have the transfer function from voltage to speed. Nice. But let's test this. Is it actually, you know, we spent 2 labs doing all this theory, doing all these parameters, but does it actually work or not? We can test it actually experimentally, and that's what the experiment number 4 is all about. So if you have a first order transfer function, which what that equation says, then when you give a constant input to a first order transfer function, the response starts from initial condition, which is 0, and ultimately reaches a constant steady state value. That's a response. So the first order transfer functions have a very peculiar step response. And let's see, if we give a step voltage input to a motor, does the response as predicted by our transfer function actually match the experimental response? That's what, you know, we're going to do over here. So we'll give some constant voltage to the motor, and according to the instructions, we're going to give voltage about such voltage so that the motor spins around 12ish radians per second, 9 to 15 radians per second. That's the range. I just picked 12. And given that voltage, we will see as soon as that voltage is given, how does the motor speed builds up as seen from the data collected by Arduino. And if that matches that experimental speed response for a constant voltage matches a theoretical one, we are good. Otherwise, you can treat this experiment as another way to measure the transfer function. Because after all, if you know what voltage you're giving to the motor and you know what the speed response of the motor is, from the voltage and the speed response, you can fit in the parameters of a first order transfer function and you can figure that out. So either this experiment is going to give us a confirmation that the theory is good, or this experiment is going to tell us, okay, here's what the experimental transfer function is. Okay, so let's get to it. Once again, and briefly just showing, I have reconnected my motor back. So it's the 24-volt power supply now, which is giving this 24-volt supply over here. That's giving the voltage to the motor. The digital multimeter is out of the picture. And then that whole circuit, extra voltage divider circuit, is out of the picture. It's just my Arduino giving the input to the motor through the DSC. Okay, so let's quickly look at the codes. Let me turn off my power supply. It was on accidentally. So the code is fairly simple. It's experiment 4, you know, the standard code, define the variables, you know, do the encoder business, and initially make the voltage 0. And suddenly we're going to give some sort of DSC value, which keeps the speed in the range from 9 to 15. Why 9 to 15? Because in future labs, we'll be trying to control the speed of this disk, and our desired speed is 12. So we're trying to do all our experiments around 12 speed so that our models are valid for the speed around 12, because that's going to be a desired speed in the future labs. Okay, so this DSC of 2400 I chose because when I look at, you know, give that DSC value to the motor speeds around somewhere between 9 and 15. So I chose that number value, DSC. So I'm going to give that DSC number, and then with that DSC number, the motor is going to, you know, we measure the disk angle, calculate the speed from it, print it all. So I'm going to print time, disk speed, and DSC value. So let's see how that response looks like. I am ready to upload this code. Let me tools, and let's check that the I want to check that the board is correct. Port is correct. Good. And now click on the upload button. Uploading, uploading, uploading. Done. I'm going to turn on my power supply. I'm also going to turn on my serial monitor. Okay, so give it a second. So there it is. And okay, so let's have a look at this response. Initially, so remember we waited in our code for, there was a delay of 3000. So yes, the printing happens inside the loop function after that delay. So of course the time printed is going to start from 3000-ish. Okay, so from 3000-ish, this is the second column is the motor speed. The motor speed is starting from 0 and slowly, actually pretty quickly, not so slowly, building up to 12. That's that step response. And the DAC value is 2400. So this is the response. This is the step response data. As the time goes from 3 seconds onwards, the speed builds from 0 pretty quickly in couple of so 20 millis 3020 milliseconds. By the time it's about 3187 milliseconds, so within like 160-ish milliseconds, it has reached the speed of 12. The motor is pretty fast. Okay, so now let's see if this experimental data is matching well with the theoretical data, and that's going to be done through this MATLAB file. So in this MATLAB file, you'll plug in all the parameters you have found so far in both the labs. You would also plug in the equation of line, which relates the DAC to the voltage, which was found in the experiment number 1. In the experiment number 1, we collect the DAC value and the actual voltage, and then we fit a line, and that was the equation of the line. So y is equal to mx plus c. So you'll fit in the parameters of that line. The voltage is m times DAC plus c. And then the MATLAB is going to plot the response of your transfer function as obtained over here, and also the experimental response. Hopefully they'll match. Otherwise, we will at least get a new confirmation of what the transfer function is, an experimental confirmation. Okay, try this out.